Moving on to the 14th topic, it is again similar to the previous videos. So first thing I would like to tell you is watch these videos in continuity. Now you must have remembered, if you have watched in continuity, you must be thorough with critical numbers, increasing and decreasing function, first derivative and second derivative. Now they have asked us to find the inflection point. First, let's see over here. When we derive the function once and equate it to 0, we'll find critical values. When we derive it two times and equate it to 0, then we will find inflection points. Now, this is what we need to solve for. Now, this is the function over here. You need to use the product rule. Remember, it is u dash v plus uv dash, and just apply. See, now this is the first function, second function. All you need to do is derivative of first function is 1, so I won't write it. Just write e to the power minus 4x. And then plus u as it is, that is x is as it is, and over here e to the power minus 4x, because the derivative of ex is ex itself. But its chain rule, derive minus 4x, it'll be minus 4. So the answer is e power minus 4x minus 4x e power minus 4x. Now over here they have written the negative term first and this positive term, because look at the product rule, it's plus. You can write this first or second, it's fine. But please don't go to do this with the quotient rule, because it was minus. You should not change that, okay? Product rule, any term, it's fine. You'll get the same answer. Now, critical numbers, just equate it to 0. But before equating, you're removing this out, common term out. E to the power minus 4x is removed out. And this is equal to 0 and this is equal to 0. Now, equate and you'll get the answer. Now, why is this not equal to 0? Look, this is undefined over here. Even undefined points are fine. It's critical points itself. But you must understand there is no value for e to the power that will make it 0, because even if this is 0, it's 1. It can never be equal to 0. Okay, you're raising something to the power, any power, it will never be 0 in this case for exponential. Now over here, x is equal to quarter, that is a critical number. Now we have to I hope you remember this very well now. Studying the sign of the first derivative, right? Where is the critical number over here? So take value less than that and greater than that and substitute in the derivative. That's over here. So all you need to do is substitute, say less than and greater than. You should use a calculator. Just you can do this simple substitution. And now if I put 0, for example, because less than 1 by 4 is 0, this term becomes 0 and this is 0, so it'll become 1, positive 1. So it's positive. And greater than 0, you need to substitute over here. It'll become minus, I believe, because this minus sign prevails. And whenever you add this will be greater because you're multiplying this, so the answer will be negative because of the minus sign. And then now we come to know this is increasing at the left side of the critical number and decreasing at the right side of the critical value. And this is just to understand about the increasing and decreasing. Now this is not over. We need to find the inflection point. That is, we need to double derive it. Now when double deriving, again we need to use the product rule. It looks complicated, but it's not that complicated if you understand this well. Let's take this. First, first function. This is minus 4. Let me keep it out. Okay, now let's do this. First derivative will be 1. In fact, I do not need to derive this because this is the same as the given function, isn't it? So if I use the quotient rule, product rule, what am I going to get after I derive? The same answer. So you've already done it once. Just write it directly. I'll just write it as it is over here because I know that is itself going to be the answer. Now, don't forget this. Derive this over here. It will become minus 4e to the power minus 4x. I've done the chain rule together. Derivative of e to the power minus 4x is same. Then multiply minus 4. Now, if you're thinking how I did it so quickly, the product rule over here, minus 4 is constant out. X e to the power minus x, when you integrate it, derive it, you have to use product rule, and we have already done the product rule over here for the first derivative. It's the same function, so I did it directly. Now multiply this inside, it'll be minus minus will be plus 16x e to the power minus 4x. Then this minus over here, minus 4 e to the power minus 4x, and this is also minus 4 e to the power minus 4x. Now we can simplify and make it short. Over here we can add these two because they are minus and minus. It'll be minus 8 4 e to the power minus 4x, and now you need to equate it to 0. Just like how we solved over here, you can solve it directly. So remove 8 common out and e to the power minus 4x common out, and then you are remaining with 2x minus 1. Now this is not equal to 0, whereas this is, so we will get x is half, and this is the inflection point. Okay, this half, this is the inflection point. If they ask only the inflection point, class, x is equal to half. Now we can again understand more of the graph by doing the concaving up or down. So take any test value, see over here less than half is 0, and substitute over here in the derived equation. See this I'll substitute because this is the same thing, simplified version. Now okay, it's anything is better. Now over here it will be 0. No, this is better, because the x's are separate. If I put x over here as 0, this is gone, and over here it will be 0, it will be 1, but this is minus 8. Minus 8 into 1, it will be minus sign, so we are minus. Same way, try 1 greater than half. Okay, over here do it in the calculator. If it's getting confusing, just instead of x, take the test value, put it over here. Same way with the right side, also take a test value, put it over here. You'll get positive, so, and negative at left side, positive right side, concaving down and concaving up. So this is the thing. This is from the second derivative. Now you can get the graph as well from all the information. From all the information we have, we can get a better understanding of the graph. See, now it is concaving. It was concaving down initially till the inflection point that is over here, and then no, sorry, the inflection point is over here. See, it's concaving down till over here, and then concaving up. And the critical number was over here. That is the maximum value. So say it was done over here, the maximum value was obtained, and see from this much we can get a very good understanding of the graph. But look into the question what they ask you. If they just ask inflection point, just stop it over there. Similarly, all problems, see x is equal to, this is a different problem, but anyway, similarly all problems are solved over here. Make sure you solve it by yourself and check the answer. Over here mainly they have just asked for inflection points, so over here if you find these second derive and equate it to 0 and find these values, that would be suffice.